Ya, Assalamualaikum warahmatullahi wabarakatuh. In here, I will to present progress thesis 1. My name is Akbar Nur and then my promoter 1 is Sir Eva Purwanto, and then promoter 2 is Hari Octavianto. This thesis, my title is Rancang bangun particle swarm optimization untuk pengaturan arus decoupling pada motor induksi 3 fase berbasis FOC. Oke. And the background is electric motors that are widely used are cheaper induction with considerance of several factors, namely simple structure, small volume, low price, easily and flexible electric driving, high efficiency and power density, high initial torque, high torque range, and broad constant power. And then my reference is 1 J Riba dan kawan-kawan, and then number 2 is electric motor alliance of standard the best practice of procurement within APEC in 2008. This is comparison electric motor drive. In here is motor DC, in here is induction motor, in here is PMSM, in here is SLM. According to Sakib Jamset Rain and Friend, published in the 2017 Chinese Journal of Electrical Engineering, discussion of comparative evaluation of the performance of several types of electric motor drive. It can be seen that induction motors are the highest rate choice for use as motor based on several considerations, factors as listed in Table 1. Okay, motor induction is a main concept of electric motor drive. In here is variable frequency, and then to scalar control and vector control. In here I choose vector control, and then choice field oriented control, and then rotor flux oriented, and then indirect field oriented. Okay, this problem in the thesis number 1 is how to control the speed of 3-pass induction motor using the field oriented control method. Number 2 is how to improve speed performance by regulating the D-axis starter current or ED on FOC-based induction motor control. Number 3 is what is the control design for the current regulator on the FOC that has good performance. Research purpose in here is 1. Designs an FOC-based induction motor control system with the setting of the current ED regulator using the PSO algorithm. Number 2 is observe to speed performance of 3-pass induction motor at low speed, medium speed, and then nominal speed by adjusting the current decoupling or ED current regulator. Offered solution from this research is vector control. My reference is M. Hanans and friend. Hack, hack performance to control fluctuation, voltage and current. It produces high torque at low speed. And then Hussein and friendly proof vector control increase energy efficient on motor drive. And then PSO algorithm, my reference is Lihang Zhao and friendly. A Zhou's PSO algorithm is utilities on the proposed model to track the variation of TF because of its simple nature in implementation and good fault tolerance. In here, my thesis real monitoring, offline or online observed induction motor performs. In here, my related research work. Contribution is it helps that this research can be usefully to improve the dynamic performance of the speed of the induction motor through setting the current ID on the FOC current regulator by using a PID controller with the particle swarm optimization algorithm. And number two is develop the few research area especially in Indonesia. In here is block diagram my thesis. And then PSO 80 current regulator in here. In here is calculation of block diagram. From flux theta calculation and the end. Okay, vector control. Vector control is FOC requires to constant input reference torque component or represented in the y-axis and then flux component represented in the d-axis. This transformation is divided into two parts, namely Karp transformation or ABC to AB alpha beta, which produce a two-time variant coordinate system, and the Park transformation alpha beta to DE, which result in a two-time invariant coordinate system. Okay, current particle swarm optimization (PSO) algorithm is a population based on random particle initialization trace and interaction between particles in the population. In this research, particle swarm optimization is proposed to look for parameter optimal PID. Okay, next, my progress thesis. In here, my block diagram. In here, in line red is software and the yellow line is hardware. Okay, in here is my simulation of lab view. PID gain into FOC, lalu tim set point RPM, SPWM inverter, permodalan induction motor model, speed position, flux observer, and then flux, current ABC, torque, position, and then speeds or RPM. Okay, my progress thesis on front in the FOC. atau field-oriented control. ABC to alpha beta to decay. And then in here speed PID, in here EG PID, in here my control is ED PID. In progress thesis, I present to random PID and PSO. Parameter PID auto-tuning in here. In here is speed response criteria PID auto-tuning. Dead time 10 ms, rest time, dead time plus 10 ms, middle under 15, under 50 ms, and then set point minus 20%. Overshoot under plus minus 2%, steady state set point plus minus 2%. Nah, and then picture of speed response criteria PID auto-tuning. In here is picture speed response graphic. Okay. Next slide is random PID. My random PID is 1008 parameter random PID. Time simulation plus minus 45 minutes. And then in here parameter range parameter P 0 to 100, parameter E 0 to 100, parameter D 0 to 10. And then in here is result random PID. Okay, in my book progress thesis, figure 31 is the result of simulation of random automatic parameter PID without optimization. All individuals who passed the speed character test use PSO. In the figure 31, it can be seen that the number parts work well. In the number 1 is base result section. The result of simulation of auto-tuning parameter PID without optimization according to table 5. Table in here. And the number 2 is the number of base result value. The mid table 5, the data is 100. And then number 3 in here is the tuning of the PID parameter, which is a very 0.10 second. Its value changes to produce the best Kp, Ki, and then Kd values with good induction motor speed performance. At number 4 is drawing set point speed and then static load use. In here I am using static load. And then in here is result of random PID without optimization, RPM 100, and then on left and on left is 100 rpm and load 0 nm, 0 nm. And then rack is 100 rpm, 5 load nm. In here is 500, and then in person is 100, and then 1500. In figure 32, 33, 34 are the result of simulation of automatic random PID without optimization of low speed, medium speed, and then nominal speed. Performance with load 0 nm and then 5 nm load. From the simulation results, if the optimization reference looks for the highest rise time, the rise time of the random PID shows the oscillation at the time of start, and then the time required for the simulation data it is plus minus 45 minutes with 1000 random PID parameter. Uh, the next result in the progress thesis, particle swarm. Particle swarm optimization or PSO optimization, PSO algorithm. PSO is a fast convergent search algorithm but is prone to getting trapped in the optimal locale, so it is necessary to determine to appropriate range of Kp, Ki, Kd value before the starting the auto-tuning. Okay, finding limitation for PSO parameter values, be selecting the best speed response from the result of the simulation that has been done. And then parameter P and range 0 to 30, parameter E 0 to 30, parameter D 0 to 30 milli. And then from the data in the table book my progress, table 8 in my book progress thesis, it can be seen that the PID convergent range is Kp 5 to 15 and Ki 7 to 15, and then Kd 2 milli to 10 milli, with its reference bit having 50% more escape data of green in that range. And then range. Okay, particle swarm optimization. Number one is the time needed for the simulation of the data is plus minus 2 minutes, and then within PSO with 20 individual and 5 population. Number two is global-based PSO algorithm is based on the greatest rest time value and then steady state speed. in his result particles from optimization. Number one in here is range optimization, range PID parameter. Number two is global base, number three is local base, and then number four is base form, PID grid, and then number five is the tuning of the parameter, the PID parameter which change every 0.10 seconds to produce the best Kp, Ki, and Kd values with good induction motor speed performance. At number 6 is display setpoint speed and static load. Okay, in here is best result of PSO algorithm. In here is very good best result optimization because the starting of speed performance motor induction is very good in here, and then maximal speed of steady state is 100 rpm. But in here on 5 on load 5 nm motor induction offer them to 98 rpm. Okay, speed 500 offer them in 5 in load 5 nm in here 0 nm 5 nm offer them. Okay, in next table is best result PID PSO algorithm. So at 100 rpm to 100 and 1500 rpm, 0 nm to 5 nm. Okay, progress conclusion is 1. The automatic auto-tuning PID parameter algorithm has been carried out with two algorithms, namely random PID algorithm without optimization with 1000 random PID parameters, and then PSO algorithm with 20 individuals or particle and 5 population steps tested using 3 speed, low speed, medium speed, and high speed. And then number 2 is the use of random algorithm without optimization requires an execution time of plus minus 45 minutes for 45 minutes, and then PSO algorithm requires only execution time simulation plus minus 3 minutes. And then number 3, progress conclusion, the result of the speed performance both auto-tuning parameter PID, random algorithm, random PID algorithm without optimization of the PSO algorithm occurred over them at 5 and 4 and 5 loads. Ya baiklah, ini adalah presentasi yang sudah saya buat. Untuk ini adalah publikasi yang sudah saya kerjakan. Ini adalah simulasi mengenai PSO tetapi menggunakan Kontrolnya V per F bukan FOC. Dengan judul metode kontrol skala dengan penala parameter PID otomatis menggunakan parameter algoritma PSO sebagai pengendali kecepatan motor induksi 3 fase berbasis lab view. Nah, saya sendiri penulisnya adalah nama pertama saya, lalu pembimbing 1 adalah Bapak Era Purwanto, pembimbing 2 adalah Hari Oktavianto, lalu untuk penulis keempat adalah Gigih Prabowo. Jurnal Sains Terapan yang diterbitkan oleh Politeknik Negeri Balikpapan pada Sinta Kemendikbud ini terakreditasi Sinta 4. Lalu publikasi ilmiah yang juga ada nama saya ini adalah implementasi atau real time yang dari simulasi tadi. Di sini adalah Institut atau disebut ITENAS. Sinta ini terakreditasi Sinta 2. Nama pertamanya adalah Hanif Hasil Farudin, teman lab saya. Lalu saya sebagai nama kelima. Oke, terima kasih atas perhatiannya. Saya sampaikan banyak-banyak terima kasih. Apabila banyak kesalahan, mohon dimaafkan. Assalamualaikum warahmatullahi wabarakatuh.